You know that moment of panic when your navigation system glitches out, leaves you totally lost?
Oh, yeah. Happens all the time. Super frustrating.
Right. Well, today on the deep dive, we're looking at something really fascinating, a potential game changer, maybe, an alternative inspired by the Earth itself.
Mhm.
We're diving into quantum enhanced magnetic navigation, MagNav for short.
Sounds complex, but the core idea is pretty neat.
Yeah, we've got some interesting research articles, a report from some recent trials too. Our mission basically is to get under the hood. How does it work? Why now? What's the big deal?
And I'm here to help connect those dots, look at the broader implications.
Perfect. Because the exciting thing here seems to be moving away from systems that are, well, kind of vulnerable, right?
Exactly. Less reliance on that satellite infrastructure we all depend on.
Okay, so let's get right into it. GPS, or GNSS more broadly, we all use it, but it's got problems.
Big problems sometimes. Jamming, spoofing, that's intentional interference.
And then there are just the inherent limits, like weak signals in cities, urban canyons.
Or indoors, underwater, even near the poles,
Yeah.
the signals just don't reach reliably.
Which isn't just inconvenient for us finding a coffee shop. It's a serious issue for, say, autonomous vehicles or defense applications.
Absolutely. And as everything becomes more automated, the need for reliable positioning, navigation, and timing PNT just skyrockets. We need backups, robust ones.
So the standard backup when GPS fails, that's INS, right? Inertial navigation systems.
That's the one. They use internal sensors, gyroscopes, accelerometers to track movement. No external signals needed, which sounds great.
Sounds good in theory, yeah. But there's a catch.
There is a big one. It's called drift. Basically, tiny errors in measuring acceleration and rotation, they add up.
Mhm.
So over time, the system's idea of where it drifts further and further from reality. Without an external check, like from GPS, it becomes pretty inaccurate pretty quickly.
It wanders off course, essentially. Needs a reset.
Exactly. It needs a reliable aiding source to correct that drift when GPS isn't available.
Okay, so INS alone isn't the silver bullet. Which brings us back to MagNav. Magnetic anomaly navigation. You said it's promising.
Highly promising, I'd say. The fundamental idea is, well, it uses the Earth's own magnetic field.
Okay.
It senses these very subtle but stable variations in the field. Think of them like magnetic fingerprints. They're caused by the geology, the rocks beneath us. They're unique patterns.
Magnetic fingerprints. I like that. That makes sense.
Yeah, it's a good way to think about it. So the system senses these patterns, compares them to really detailed magnetic maps.
Ah, okay. Like matching the print.
Precisely. And that's how it figures out its location. Now, historically, the sensors just weren't, well, good enough.
Too much noise. Or not sensitive enough.
Both, really, especially trying to detect these tiny variations from something that's moving, like a car or a plane. But that's where quantum technology comes in.
Right, the quantum magnetometers. That's the game changer part, specifically OPMs.
Yes, optically pumped magnetometers, OPMs, they are incredibly sensitive and stable. Much better than older tech.
So they can pick up those faint magnetic fingerprints even on the move.
That's the breakthrough. They offer the performance needed to make MagNav truly viable. And think about the advantages. Unlike GPS, it doesn't need a clear view of the sky.
Right, works indoors, underwater.
Exactly. And unlike systems that have to send out a signal, like radar, it's passive. It just listens, which is huge for, say, defense.
Okay, passive, works anywhere. And you mentioned it offers positioning accuracy that stays within a certain range, like GPS. It doesn't just drift off forever like INS.
That's the potential, yes. Bounded error, we call it. It stays accurate because it's constantly referencing those magnetic map features.
Okay, this sounds really powerful, but it hinges on those maps, doesn't it? You need the fingerprint database to compare against.
You absolutely hit the nail on the head. That's the other critical pillar. You need two things for quantum MagNav to work: the super-sensitive quantum sensors and incredibly detailed, high-fidelity magnetic anomaly maps.
And the quality of those maps directly impacts how accurate the navigation is.
Directly. Especially as you go higher up, like in an aircraft. The magnetic signals get weaker, so you need even better maps to distinguish the features. Creating and maintaining these maps,
Yeah.
it's a huge undertaking. It's actually a big part of making this technology practical.
So it's not just about the quantum sensors, it's equally about the data, the map making.
It's a complete system. Sensors and maps working together.
Wow. Okay. So we've journeyed from the annoyance of a glitchy GPS,
Uh-huh.
to understanding the limits of current backups like INS, and now to this idea of using the Earth's own magnetic field supercharged by quantum sensors and needing these amazing maps. If we boil it down, what's the main takeaway here?
I think the core insight is that this quantum-boosted magnav offers a really significant step towards positioning that's reliable, that's resilient, especially where GPS struggles or, frankly, can be easily disrupted.
It really feels like we could be on the cusp of a major shift in just how we know where we are. So, for you listening, here's something to chew on. If this tech keeps advancing and we get highly accurate navigation that doesn't need satellites, what happens next? What kind of unexpected things could that unlock? For autonomous systems, for, I don't know, exploring parts of the planet, what new view does it give us of Earth's hidden magnetic self?
That's a great question. The possibilities that open up when you remove that reliance on space-based signals,
Yeah,
they could be quite profound, maybe in ways we haven't even thought of yet.
definitely something to ponder.